Hi everyone. So in this video, I'm going to attempt to connect Rawls Theorem with the mean value theorem. Because Rawls Theorem is really just a special case of the mean value theorem. So I'm going to do this with pictures. So let's look at Rawls Theorem. So remember that Rawls Theorem says that if we have a function over a closed interval that is differentiable over the open interval, then where our outputs of the endpoints are equal, then we will have some value c where, so some value c where we have a horizontal tangent line. Now, the mean value theorem, I almost said intermediate value theorem, the mean value theorem says something very similar. So I want you to imagine taking the same graph above and just rotating it. So I'm going to use the same closed interval, and we're just going to move f of a up and f of b down and try to draw the same graph here. The mean value theorem says that there exists some point c such that the slope of the secant line is the same as the slope of the tangent line. So we have the slope of the secant line here and the tangent line here, and it's saying that this c exists such that the slope of these two are the same. And I want you to see that this is a more generalized case of Rawls theorem. So looking here, the slope of the secant line, so the slope of the secant line equals f of b minus f of a over b minus a. And the mean value theorem says that therefore there exists a c such that the slope of the tangent line equals the slope of the secant line. Well, in Rawls theorem, the slope of the secant line is 0 because the slope of the secant line connecting f of a to f of b is horizontal since f of a equals f of b. So the slope of the secant line equals 0. And Rawls theorem then said that there exists some value c such that the slope of the tangent line equals 0. Essentially saying that the slope of the tangent line is the same as the slope of the secant line. So I hope this helped to show you how these two theorems are connected. If you want to see the proof of the mean value theorem, it's in our text on page 382 to 383.